today's lesson, which is on lesson 3.3, we're going to take a look at exponent laws for when we are power of a product and a quotient. So just a quick review. So when we have a same base and we're multiplying, what we can do, the base stays the same and we are going to add the exponent for multiplying. On the other hand, if we're dividing, the base stays the same. We subtract the exponent. And when we have a power of power exponent right beside each other, then we will be multiplying m times n. Okay. Now let's try some questions over here. Let's try number 1. So I want you to simplify to a single power first and then evaluate. So we notice that, okay, so let's do the bed mass. So it looks like inside the bracket, I have a same base of 3, 3, and 3. So what we can do is we could apply the exponent law. So 3, so because we're multiplying 1/3 plus 1/2. And then we're going to subtract, because it's dividing, subtract negative 5/6. Okay, negative 5/6. And then we have 3 outside the bracket. So you can make the same common denominator, or you could use a calculator. 3 to an exponent of, so the lowest common denominator will be 6. So I'll be multiplying 2/6 plus 3/6. And negative becomes positive 5/6 to the power of 3. And we add the numerator. So it looks like we have 3 to the 10/6 to a power of 3. And when we have power of power, we can multiply 10/6 times 3. But it looks like I can simplify. So 3 divided by 3 is 1. 6 divided by 3 is 2. Okay. So then it looks like we have 3 to the 10/2. So 10/2 is 3 to the 5. So this is a single power. And then you have to evaluate, means no exponent. So I'll be doing 3 times 3 times 3 times 5 times, and that should give me 243. Okay. Now, what about the next question over here for letter B? So we have a power of power of power. So when we do, all we need to do is just multiply. 2 times 3 times 4. So it will give me 4 to the 24. And then minus, again, it doesn't matter if it's negative or positive. When we have a power of power exponent right beside each other, we're going to multiply. So it will become 4 to the negative 3 times negative 8 gives me 24. Sorry. And therefore, now that because it's subtracting, we cannot apply the power law, right? It's only when you're dividing it, you subtract the exponent. But in this case, 4 to the 24 minus 4 to the 24, a same number you subtract, it becomes 0. Okay? So rule of thumb, I don't want you guys to get confused. A to the m divided by a to the n is a to the m minus n. However, a to the m minus a to the n, you can't subtract it, even though it's the same base. Because it's a subtraction, that's there to it. Okay, you cannot simplify any further. Okay, so exponent law only applies when you are multiplying the same base, or dividing the same base, or right beside each other, power of power. Now, if you take a look at number 2, it says express as a power of the base indicated. So we have 27 to the power of 3, and I want you to rewrite it as a base of 3. So what you need to do, well, I need to figure out how can I change 27 to a base of 3. Well, you can do trial and error. Like 3 to the 1 is 3. 3 to the square is 9. And then 3 to the 3 is 27. So you keep multiplying using a calculator. So I can replace 27 with the 3 to the 3. And then power of 3. So therefore, the exponents are right beside each other, so we can apply the power law. So 3, we're going to do 3 times 3, which is 9. Okay, so this is another way to represent 27 to the 3 as same thing as 3 to the 9. Okay. Now, so let's take a look at some of the review questions here. So what you can do is when we have a power with the same two terms here, remember that 6 applies to y and x, to all the variables inside the bracket. So therefore, this is a long expansion one, but the short one, all we can do is x to the 6 and y to the 6, because there's invisible x to the 1, y to the 1 to the power of 6, so you multiply. Okay, same thing. When you have like a division, 4 applies to the numerator and for the denominator. So it's x to the power of 1, so 1 times 4 is x to the 4, and then y to the 1, because there's invisible x to the 1, y to the 1, and you are multiplying 1 times 4 and y to the 4. Okay, so lastly, same thing. This 3, I can't really simplify inside the bracket because they're all different bases. So this 3 will be multiplying with y to the 3, x to the 2, and z to the 4. So it will be x, 2 times 3 is 6, y, 3 times 3 is 9, over z, 4 times 3 is 12. And that's how you simplify. So in summary, what do we know? So when you have, like, let's say a different variable inside the bracket and you have a power, this exponent applies to all the different variables. So in this case, it will be a to the m times n and b to n. So what you're going to do to simplify power of a product because it's a to the m times b, right? When they're right beside each other, the multiplication is hidden. They will be they share the exponent with each factor of the base. So same thing here, n will be applied to b, a, d, and c. So it will be a to the n, b to the m times n, over c to the m times n, and then d to the n. So same thing for division. They still share the exponent with each factor in the numerator and the denominator. So for example, when I have a question like this, I will be applying to the numerator 2 to the 4, because there's invisible 1 times 4, and 3 to the 4. And you can evaluate this by 2 to the 4 is 16, 3 to the 4 is 81. So this question is simplified. And this question, when I get rid of the exponent, it means evaluate. Okay, so make sure you understand what the question is asking. Okay, so let's dive into the question right away. So let's try number 1A. So it looks like I have two different variables here, okay? Or we have a coefficient. So we have 2. So 5 is going to apply to the negative 2. And 5 is going to apply to the base of A. So using bracket, negative 2 to the 5. And then A to the 3 to the 5. And then negative 2 to the 5 is going to give me negative 32. And A, 3 times 5 is going to be A to the 15. Okay. Now, what about this one for letter C? Now, for letter C, what you can do is I would simplify inside the bracket first. So we have 4 and 3 as a coefficient, and we're multiplying. So I would multiply these two first, which is 4 times 3 is 12. And then A stays the same because there's no same base, and B to the 4 stays the same and squared. And then after that, this power of 2 applies to B, to A, and to 12. So therefore, it's going to be 12 squared, A squared to the square, and B to the 4 squared. So 12 squared is going to give me 144. You multiply, A, 2 times 2 is 4. B, 4 times 2 is 8. And that is your final answer. Okay. Now let's try letter H here. Now, as you can see for letter H, look inside the bracket, right? Bedmass. I can't simplify anything because they're all different bases. So what I can do is I could just apply 3 to the B, to the negative A to the 3, to the C, and to the 3. Okay? So don't forget, it's you can consider negative A to the cube, or you can consider like there's invisible 1, negative 1. So you could say negative 1 to the 3, and then A to the 3, B to the 3, all 3 of them, including the coefficient negative 1, 3 to the 3, C to the 5 to the 3. Then let's simplify. So negative 1 to the 3 is going to give me negative 1. And it's going to give me A, 3 times 3 is 9. B to the 3 over 3 to the 3 is going to give me 27. And C to the 15. Okay. So this will be your final answer. But usually 1 is invisible, so I could just omit 1. So it's negative A to the 9, B3 over 27, C to the 15. Okay. Now I do want you to understand that negative position, it could be at the top, middle, or the bottom. So for example, if I were to have negative A over 5, this is same as negative in the middle, A over 5, or A to the negative 5. So it could be at the top, in the middle, or at the bottom. But it cannot be at the both places. Because if I were to have negative at the top and negative at the bottom, negative, negative becomes positive. So you have to decide, am I going to put it numerator, in the middle, or the denominator? Okay. Now let's try number 2. So we want to simplify using the exponent laws, and then we want to evaluate by plugging these numbers. Okay. So let's try number 2A. So it looks like they are separate. notice how we have the numerator and the denominator with 4 and 3. So what I'm going to do is I'm going to apply to each different variable, to b, to the a, and to the 2/3, to the b, to the a, and to the 2/3. Okay, so let's start. So we have 2 to the 3, 4, a squared, 4, b4, 4. So that's the numerator. I applied the exponent law by multiplying. And then at the bottom, we have 2 to the 3, 3, a squared to the 3, b5 to the 3. And then I'm going to simplify. So I could do, so I'm not going to expand yet. The reason why is because I noticed that we have a same base here, right? But I could simplify these, exponent, power of power. So it will be 2 to the 3, 4, a, 4 times 2 is 8, b, 16, over 2/3 to the cube, a, 2 times 3 is 6, b is 15. Now I am going to apply the exponent law. When we're dividing, we subtract the exponent. And in this case, we have a same base of 2 over 3. So therefore, 2 over 3. So because we're dividing, I'm subtracting the exponent. 4 minus 3 is 1. A to the 2, 8 minus 6 is 2. And then b to the 1. Okay, good. So now we can simplify. Anything the power of 1 is just invisible. So 2 over 3, a squared, b. So if you want, I could put it right beside it, or you could write it at the numerator, but not the denominator. So because it's, remember it's 2 over 1, b over 1, right? So I could put it as 2a squared b over 3 if you like. Now we know that a is going to be 3, so I'm going to plug it in. So 2 bracket, a is 3 squared, b is -2 bracket over 3. So using your calculator, I'm going to simplify. 2 times 3 to the square times -2, and then divided by 3. So when you do this, you're going to get -12 as your final answer. Okay, so you're going to do same thing for number 2b. Okay, for when you're doing number 2b, don't forget, for number 6, it applies to the b, to the a squared, and to -1, because there's invisible -1 here. But for the first bracket, there's no exponent here, so you just leave it as it is. Okay, so you will try that. The next section is we're going to talk about the zero and negative exponents. So again, reminder, a m plus n, a m minus n, a m n, and then this applies to all the different variables in the bracket. So it's a to the n, b to the m times n, over c to the m n, and d to the n. Okay. So let's try number 1a. So if you take a look at number 1a, we want to simplify using exponent laws. So we have a different base here, 3, 2, and 6. So I cannot apply an exponent law right? Because they have all different bases. So what I'm going to do is I'm just going to apply the power of power to the base of 2, to the base of 3, and to the base of 6. So it will be 3 to the 8 to power of 1 over 2 times 2 to the 4 to the power of 1 over 2 over 6 squared to the power of 1 over 2. And then after that, so I'm going to multiply 8 times 0.5, which is going to give me 4. 3 to the 4 times 2. 4 times half is 2 over 6. 2 times 1/2 is going to be 1. And then I can't apply the exponent law again, so I'm just going to evaluate it. So 3 to the 4 is 81. 2 to the 2 is 4 divided by 6. So when you multiply and divide, your final answer will be 54. Now, if you take a look at number 2, number 2 is a thinking question. Very good question. The question says simplify and evaluate. So you notice that the base is all different, 32, 4, and 16. But they share a same base, which is a base of 2. So I can simplify by changing all of these different bases in terms of 2. So using trial and error, well, use your calculator. You will notice that 32 could be represented as 2 to the power of 5. So you will do 2 times 2 times 2, okay? So instead of writing 32, I'm going to write 2 to the 5 to the power of 5. So I just replaced 32 with 2 to the 5. And then over 4 could be replaced by 2 to the 2. So instead of writing 4, I'm going to replace 2 to the 2 and then exponent of 2 times 16 through trial and error. You will notice that 2 to the 4 will give me 16. So I'm going to replace 16 with 2 to the 4 and then exponent 4. Now that I have a same base, I'm going to apply the exponent law. So multiply, because they're right beside each other. 5 times 5 is 25 over 2 to the 4 times 2 to the 4 times 4 is 16. And now what we need to do, because they're all the same base, I'm going to apply the exponent law. So I could simplify these two first, right? Which is 2 to the 25 over 2 to the 20, because I'm multiplying. And then 25 subtract 20, because it's dividing, it will give me 2 to the 5. And then I could evaluate 2 to the 5 is 32. And that will be your final answer. Okay. Now let's take a look at the next rule that we have to know for more exponent laws. Anything to an exponent of 0 is always going to be equal to 1. So it could be like n to the 0 is 1, or 5 to the 0 is 1. Okay, so exponent with the 0 is always going to give you the answer of 1. Now when you have a negative exponent, we don't like negative exponents, so what we're going to do, we are going to take the reciprocal. So a essentially means a over 1. Right? So to get rid of the negative, I am going to flip this. So when I flip it, it becomes 1 over a, and then the exponent now becomes positive n. Now I could replace this to be 1 over a, and then n could be at the top as well. Okay, but usually I like to put it at the bottom like this. Okay. So then next, if I have a fraction with a negative exponent, same thing. We're going to flip it. So if I flip it, it becomes b over a, and the exponent will now become positive n. Okay, so these are the 3 rules that you must memorize. So to evaluate, in summary, a power with a negative exponent, you're going to take the reciprocal, so it means you're going to flip it, of the base in brackets and raise it to the positive exponent. Turn it into positive. Okay. Okay, so let's see. 0 and negative exponent laws. Let's do a quick review. A to the 0 is 1. And then we have a negative inside the bracket. So this will still give me 1. But over here, this is different. There's no bracket here. So 0 doesn't apply the negative as well. So what this really means is that if there's no bracket here, it's negative. It only applies to a to the 0. Because 0 is only beside a. So a to the 0 is 1. So my final answer is negative 1. On the other hand, the second one, negative, it's inside the whole bracket. So whole thing to the power of 0 is 1. So please be careful on the test. When I have a negative exponent, again, same thing. I flip a to the n, and n becomes positive. Same thing, if I have a fraction, I flip again, b over a, and the negative exponent becomes positive n. And if I wanted to expand, I could apply to b and a. So I could write it as b to the n over a to the n. Now, what if you were to have a negative in the denominator? Okay, so same thing again. If you have negative, I'm going to flip them. So let's flip. It becomes a over 1, and negative exponent now becomes positive. So it becomes a to the n. Okay, so let's try some practice question. So we want to evaluate using exponent laws. So for number 1a, we don't like negative exponent, so let's flip 2. 2 essentially means it's 2 over 1, so I'm going to flip it. So it becomes 1 over 2, and negative 4 now becomes positive 4. And I can evaluate it. So it becomes 1 over 16. Now what about letter B? I have a negative exponent again. I don't like it. With fraction, I am going to flip it again. So it becomes 3 over 1, and the exponent now becomes positive 4. And this 4 applies to the 3 and to the 1. So 3 to the 4 over 1 to the 4. And then 3 to the 4 is 81. And 1 to the 4 is just 1, so it's just 81. Okay. Now what about letter D here? So we have negative 3 to the 0, but negative, it's not inside the bracket. So negative stays outside, but 3 to the 0 is 1, right? Anything to 0 is 1. Plus, we don't like negative exponent, so I'm going to flip 5. So it becomes 1 over 5, and then negative 1 becomes positive 1. So in order to add them, I'm going to make a same denominator. So I'm going to multiply negative 1 with 5. So negative 5 over 5, right? Plus 1 over 5. And then negative 5 plus 1 will give me negative 4 over 5. And that will be your final answer. Now let's try letter G. Okay. Now for letter G, we cannot apply the exponent law here because it's subtracting and adding. Exponent law only applies when you're multiplying or dividing. So what we can do is, I'm just going to apply the exponent law where negative will turn it into positive exponent. So for the numerator, it becomes 1 over 2 to the power of 3 minus 1 over 2 to the power of 1. I flipped it so it becomes positive, divided by 1 over 4 to the power of 1 plus 1 over 4 to the power of 2. So therefore, let's simplify. So 2 to the 3 is 1 over 8 minus 1 over 2 over 1 over 4 plus 1 over 16. So I'm going to make the same denominator. So I'm going to multiply this by 4. So this becomes 4. And I'm going to multiply this by 4 to make 16. So this now becomes 4. So therefore, it's going to be 1 minus 4. 1 minus 4 is negative 3 over 8 divided by 4 plus 1 is 5 over 16. Now when you have like a fraction of fraction, don't be discouraged. All you need to remember is this rule. Inside and outside. So what you're doing is you're multiplying the inside and the outside, and the inside will become at the bottom. So 8 times 5 inside, 8 times 5 at the bottom, and the outside becomes at the top, negative 3 times 16. Okay. And then you simplify, you're going to get negative 6 over 5. Now, remember, outside becomes at the top, and the inside is at the bottom. Now, if this is too confusing for you, you could rewrite this as negative 3 over 8 divided by 5 over 16 using division symbol. And with dividing fraction, what we need to remember, we're going to flip the second fraction. And once we flip it, the division becomes multiplication. So it's negative 3 over 8 times, but we're flipping it, 16 over 5. This is the rule with dividing fractions. And then we're back to basic. It looks exactly the same, which will give me negative 6 over 5 after you simplify. Okay, so let's try number 2A. It says simplify to a single power and then evaluate. So there's two parts to it. So I want you to put it in one single power exponent and then get rid of the exponent. So we notice that we have a same base here and it's all dividing. And 2 has invisible 1 as an exponent. So what we're going to do, the base stays the same, but for the exponent, I'm going to subtract negative 4 minus 1 minus negative 11. So you can use your calculator. Negative 4 minus 11, and negative becomes positive 11. So once you punch it in, it becomes 2 to the 6. So we just simplify to a single power. And then in order to evaluate, punch it in 2 to the 6, like 2 times 2 times 6 times, and that will give me 64.